Welcome to our next installment of MR3 101. Today I want to talk about signal processing techniques available in MR3 and how to apply them to different signals in real time, as well as after a recording has been made, or if you need to make any edits to your signal processing. Typically, signal processing is applied to a signal to either help improve the signal quality, reduce noise artifacts, or to even emphasize certain aspects of a signal in the analysis. And MR3 has a lot of different options to be able to use within the software for signal processing. And that can include tools for applying to the time series data, or for perhaps also in the analysis aspect by running reports and running different statistical options. For today's session, we are going to focus on applying the signal processing to the time series data and seeing how that can manipulate the signals that we're working with, which ultimately can be used in further analysis. And so I first want to get into discussing the ability to apply the signal processing in real time. This allows you to utilize different signal processing techniques and have those be applied to the signals ahead of the time so that as you continue using that selected measurement configuration for any measures, you'd have that same processing techniques applied to those signals every single recording. And it really helps make that overall workflow very efficient, because you don't have to manipulate or edit anything on the back end. You simply can just move right into the analysis side of things. So we're going to go ahead and start this by selecting our configuration here and clicking Edit Configuration. That brings us, in this case, we're using EMG. It brings us to our menu where we're going to select the different channels that we're using. And you'll see on the right side toolbar, there's this option for online processing. When I select that, a menu pops up that presents the different methods that are available to us. You can see that there's several here, and as you select them, you'll see a different description of that particular method and what it will allow you to do. Another thing is that we have our online help built in. And so if you click that question mark button, another menu will pop up. And essentially, this is going to give you information about how to use the different signal processing or real-time processing tools, how to apply them, and then, of course, even some information about the individual settings that can be adjusted. So I always recommend people to look at that online help. And again, that can be accessed by clicking on the question mark in any of the windows that you're working within. In this case, the real-time processing menu, but we also have it available within the green action bar here if you're using any other feature of the software. So, any of these different processing options, you can apply multiple methods, and they're going to be run on the signals going from top to bottom. So they do have an order to them. In our particular example today, we're going to be working with EMG channels. And so I want to, apply some different techniques that are maybe a little bit more typical with an EMG signal. But you'll see here that there's different options available, whether it's, just applying an ECG reduction, which is going to filter out any artifacts from an ECG signal. Perhaps you're measuring EMG on the pectoral muscle or on the spinal muscles. Sometimes it creeps through there. Rectification, we can make all of those negative values positive. Smoothing smooths out the different signals based off of, a few different types of algorithms, as well as a smoothing window. So how much data is it averaging over a certain period of time? Amplitude normalization to allow you to apply a max voluntary contraction in real time. Different frequency cutoff filter options to filter out certain artifacts that may be from environmental effects or motion, for instance. We can apply a time offset to a signal if we need to, push it forward in time and have it be better synchronized. This is not typically used that often with our Naraxon systems, as those are going to be automatically synchronized with one another. or if you have the sync settings set up for even some other analog devices. But otherwise, you can always apply that time offset if you need to. And then we've got the derivative and the integrals here. So applying those two calculus methods to any of the signals that you might need, whether that's accelerations or angular data, any of those can be applied. So again, we're going to focus on some EMG options here, and we'll use the order of the methods to insert them. And so to insert those signals, we first have to select it, and we can double click on that method to insert it into the menu here. You'll notice for each one of the methods, they're going to have some different settings that are available for you to affect. And so for instance, we'll add in smoothing. You can see there's some additional settings here, and then amplitude normalization to apply that MVC. Now, if I go back up to the filtering here, I'm going to switch this to, maybe a more standard frequency cutoff filter used for EMG, a high pass filter. And for instance, in this one of the settings is this bidirectionality. This should be applied because oftentimes when you utilize an infinite response filter, it introduces a phase shift in the signal. So it pushes the signals forward in time. Applying this bidirectionality essentially runs that same filter backwards and resets that phase shift that was seen in the first iteration. So we'll click this high pass filter. We'll choose just arbitrarily pick 20 hertz here. We've got different approximations available, and that's going to be the case for any of these methods. There may be a drop-down menu available in the settings that allows you to change what type of technique might be applied within that method. Another thing that you'll notice is that you can apply these signal processing methods to channels by type, in which case we just have all of our EMG channels. Or if you click this here, there's another drop down and it allows you to apply the channels by number. That gives us the option to select individual channels that we want to apply this signal processing method to. For instance, that might be utilized in the case of the ECG reduction filter. You wouldn't want to apply that to all of your EMG signals, but only the ones that are affected by that ECG waveform. And so using the channels by number, you can make those individual selections that you want to use this method on and have that be inserted just for those channels alone. I'm going to go ahead and switch back to channels by type and apply these to the EMG. We'll move down to our smoothing here. Again, we've got options to change these settings, and we'll go ahead and just change this to a 100 millisecond smoothing window. Same things you can apply to the channels by type or number. As far as the amplitude normalization is concerned, we've got our window that we will calculate that MVC with, and then the option to set the y-axis amplitude for when it is converted to a percentage. Any of these other options will also have settings to change, and perhaps we'll get into some of those here after we get through this initial recording. But once you have your different methods set up and applied here, again, they're going to run in order from top to bottom. So make sure you do apply those filters in the right order if that matters. But once they're set, all you need to do is click OK, and those different signal processing methods are going to be applied to your signals going forward. So in real time for that measurement that you're going to be moving into. And you'll notice that the configuration now, over here in the measurement options, that online processing is illuminated, indicating that you've got some processing methods applied. This is going to save to this particular configuration, and so every single time that you use this measurement configuration, those same processing settings are going to be applied to the signals. And again, that just helps with the efficiency of the overall workflow. Allows you to not have to worry about going through and applying all of the same processing techniques to every single recording after the fact. Additionally, you can even see how the processing techniques might affect your signals in real time. So to see that, we'll go ahead and click Start Measure. In this case, I do have that amplitude normalization applied, and so that gives us a button over here in the right side toolbar that says Make MVC. So if I click that, it's going to put us into that mode where we get the MVC values. The other thing though is that you can see the other processing techniques applied. So this is going to be that high pass filter as well as that smoothing window. And one thing to note about the smoothing window is I did use an RMS filter, and that actually automatically rectifies the signal. So that's why we still see these rectified signals here. When in live view, you can still always view the raw signals. So there is this toggle button down here that allows you to switch back and forth between the data types. And of course, that raw signal is always nested underneath in the recording. And so even after the fact, if we want to remove all of this processing altogether, we can certainly do that. Right now, we're going to record our MVC, and you'll see that will then apply to the rest of the signal. So if we click record in the green action bar here, you can see that it's telling us to press stop to save the MVC calibration data. We'll go ahead and let that run for a couple seconds. Hit stop. And now we've got our MVC recording that was made. So if I click save and view, you can see that the MVC stack was updated and our data has been converted to this percentage value. And we still maintain the other signal processing methods of the smoothing and the frequency cutoff filters that we had set up. So now we're in the viewer section of the software. And so if we wanted to make any adjustments to this, we would be able to open up the signal processing menu here. And we can change what signal processing might be applied to this particular recording. The menu, when you pull it up, it'll just show the last two operations that you had used, or sorry, the last operations, not necessarily two of them. And so we'll go ahead and delete those so that we can make some changes. And perhaps we want to change that filter. We want to change it to instead of a 20 hertz high pass filter, we want to make it a 50 hertz high pass filter. We have options to select which channels we want to apply these methods to again, except a little bit different menu here. You can drill down in some different ways to the signals that you want to get access to. This is mostly going to come into play when you've got multiple devices that you're using within the platform here. But then we just continue to add in these other options. So we changed our frequency cutoff filter. Let's go ahead and change our smoothing signal as well. We'll do 300 milliseconds instead of 100 milliseconds. And then for the amplitude normalization, we want to change our window to be 500 milliseconds instead of 1000. And that amplitude normalization window, just so everybody knows, is indicated by this green shade here. So when you do apply amplitude normalization and you record that MVC, this is where it's going to be grabbing that MVC calibration from. And of course, if you were to move into another measurement using this configuration, it would actually apply that normalization to the signals moving forward. And again, show the data in percentage here. But with all of these different methods changed now, one thing that's very important is that we actually go from the raw data. So we want to use this clear processing first option down here, because we want to apply these different operations from the raw format of the EMG data. If we did not have that checked, it would apply these operations to the already processed data. So actually what you're seeing here, as opposed to those EMG bursts that we were looking at previously. So we'll go ahead and check that. One thing to always check rather, is to look at the preview screen. And so we have this option down here to be able to show you how these different operations might be affecting your signal. So if I click preview, you can see not only does it adjust where that MVC stack was pulled from, you can see that there's the different normalization values shown in these parentheses. But you can also see how the data is even more smooth, right? Because we chose that 300 millisecond smoothing window as opposed to the 100 millisecond smoothing window. So this preview option really is a nice helpful tool to be able to understand how these different techniques might be affecting your signals. This is a great tool to use in forms of education. So if you're ever teaching students about how to utilize or understand different options when you're talking about frequency cutoff filters, for instance, or smoothing windows, using that preview and seeing the signals overlaid on top of one another really gives a great understanding of what the different settings do to the signal and how it might manipulate or alter that data overall. But that gives you, full control to be able to make little small adjustments, subtle adjustments, and optimize the signal processing approach for, the application or the data that you're working with. When you have this saved and you want to, or applied and you want to have it saved, you can go ahead and click OK, and now that information will update. So in this case, you can see our MVC stack was updated, and then we've got that, 300 millisecond smoothing applied, so a little bit less jagged peaks that we were seeing from the previous signal. The other option that you can do is even apply some signal processing that's, a little bit different. So not in the sense of, cutting off certain frequencies of the signal or applying smoothing, but, utilizing two signals or a function with multiple signals to create a different signal altogether. And that's actually shown within our formula option here. This is a new feature to MR316, and so we can go ahead and select that. And just to keep it rather simple, maybe we want to add two of the signals together to create a sum signal, for instance. So in this case, I'll go ahead and clear this expression out, but we can double click, hit plus, and double click on the other biceps signal and get that sum signal between the two options here. We can apply the name, so we'll just call it sum biceps. Summed biceps, and our units are going to remain as a percentage, so we'll keep that. And then there's this all-in-one graph option. So basically, does it, do you want it to apply the expression and then put the two separate signals along with the sum signal all in one graph? Aside from the expression, we can also write functions. These are going to be more complex mathematics or calculus that you would want to apply to different signals. And so those can be edited, and this is Python based, and so it gives you the option to really dive deep into some neat signal processing options using customized functions or expressions. But in this case, we'll stick with our simple expression here, and when we're ready, we just have to click Create Channel, and then that's going to give us our formula channel here, which is the summed biceps. And so if we were to overlay these signals on top of one another, for instance, the biceps on top of the biceps, and then our sum signal on top, you can now see that it is that double signal or that added signal, giving our summed equation for the biceps here. Still represented in that percentage value, of course, because that's the units that we set for it, and gives us the option to again see how those signals are summed here. In this case, 210, 104.6 plus 105.1. Rounding up a little bit. We can change that significant digits if we need to. But that's another form of processing that we've got built into the system, which offers a bit more customization this time around, as opposed to some of the point and click operations that we've got available in the other signal processing menu. One thing to note about this is we can certainly save different configurations. So if you've got expressions that you're going to use continually, or perhaps a very detailed function that you spent a lot of time writing out, you can save that formula and you can continue to load and use it going forward. You can see here we've got a couple already integrated, in window averager or magnitude signal, and those can be just selected and then hit load, and you can see, for instance, that code will integrate here and give you an option to be able to use those saved operations time and time again. Going back to our other signal processing options, one thing to mention is that we can certainly apply batch signal processing. So for instance, let's go ahead and click the signal processing menu here. You'll notice that on the right side, there are these configurations. And so these are actually saved options that you can use to either apply to multiple signals at once, or for quick access when you get to the selection menu. rather than filling in the different operations one by one and making those settings, you can save a configuration so that all you have to do is just double click and then it changes that. If you double click, of course, it gives you that preview first so you can see it applied and how it makes those manipulations to the signals. If everything looks good, you just click OK, and then that's the new setup. How you use that in a batch processing situation is actually from the database. And so if we go to the database here, we can select multiple recordings, and these are going to be multiple recordings that I had previously. And actually, let me go ahead and just remove the processing from this one just so you can see what I'm talking about. And we'll go ahead and do that for all these others real quick. We're back to raw. And these are all just sample recordings that I had made with the player data that's available in MR3. Great tool to use if you don't have any hardware plugged in and you want to manipulate or play around with some different functions. But for instance, when we do want to apply that batch processing, what we can do is make a selection of different recordings. And they're going to be within subject, so you wouldn't be able to do that for multiple subjects at one time. You'd have to actually go to that subject, make your other selection, and do the batch processing methods. But in this case, we'll stick within our EMG test subject, make our selection. I'm doing that by click, hold, and dragging down. We also have the option to use the keyboard selectors, like for instance, if you hold Control, you can choose individual recordings within the list. Other things that you can do is if you hold Shift and you click, first make one selection, hold Shift, make a selection down the list, it's going to select all of those recordings in between. So with that, I've got 4 recordings selected. And now to apply batch processing, I just have to right click anywhere within that selection. And you'll see that this menu pops up and allows us to apply this batch processing here. You can see that the 300 millisecond smoothing is shown here, and so that'll be the one that we utilize. And there's of course the option to clear processing first again. So if you do want to alter your processing, make sure that you understand if that's going to work and manipulate the data from the raw signal as opposed to an already processed signal. So we'll go ahead and just click this, even though we were working with the raw signal, but just as a reminder to check that. Otherwise, we just select it and click OK. And now that processing is applied to all of these recordings. We can understand that by, of course, viewing them, but then there's also this info pane that can be toggled on and off, and there's a tab called Processing History. And so that'll show us the processing methods that might have been applied to any of the signals in our recordings. So you can see here a bit more detailed information on this one. Or an MVC, for instance. Whoops. Normalized. Those configurations, of course, you can make multiples of them. You can see here that there's plenty of them available in this this right side window. And essentially all you have to do is just fill in, your settings that you want to use. And, for instance, if we do this high pass filter again, we'll do 50 Hertz. We can hit save and we can call it 50 Hertz high pass filter. You can choose a cool icon if we'd like. And then all we have to do is just click OK, and that's going to save. And now you can see that it's available in this list. And so you can fill this out with as many of these different configurations as you'd like. But again, it just helps with more quick access, to this signal processing type. And then, gives you the ability to do that batch processing as well. So moving away from EMG, of course, there's options to do some additional signal processing to other types of signals. Maybe it's not smoothing, but for instance, you want to work within a record with the IMU system and you want to apply some processing to an acceleration signal. So if I pop these out, for instance, we can see we've got, nice and messy acceleration signals to work with. And so, perhaps we'd want to filter those out, take out some of the reverberation or rectify it and look at different acceleration peaks. And so for instance, we would just still apply our signal processing here. We can choose any of those options that we see. Maybe we do a rectification and a mean smoothing. So first, when we choose the rectification, we want to click type and do accelerations. And then that drills us down into 21 different signals. And then we can choose something like name and then pick the specific signal that we want to actually apply this to. So in this case, we're going to just do the pelvis here, since that's what we're working with. The other thing is, maybe we also want to add a little bit of a smoothing algorithm. So not only just rectifying it, but maybe smooth it out by a mean, average, really small or light smoothing window, in this case, 10 milliseconds. You'll see that the selection is saved from the previous operation. So unless we need to make a change to that, you can just keep it as is. Of course, looking at that preview option here, seeing how it actually affects the signals. In this case, maybe we look at the Z acceleration in particular. You can see that rectification happening. You can see that little bit of smoothing as well. And you can make those adjustments. So if we want to try out a different smoothing window, for instance, we can see how that makes that change. We can change it to an RMS smoothing algorithm as well. See the adjustments. So using that preview is, again, it allows you to really optimize the signal processing options that you're using. And, of course, you can apply multiple signal processing types within these operations. You don't always have to do it to the same signals. Excuse me. So for instance, we've got this applied to our acceleration signals, but what if we wanted to also apply, something to one of the anatomical angles? In this case, if we look at hip abduction. So we've got our hip abduction signal here, and we want to turn this into a rotational velocity signal. So we can apply a derivative to that signal, and we just have to change these settings. With the derivatives and the integrals, really there's only settings to change the scalar and the divisor, so just applying a coefficient to the calculus, and then you can decide what units that you want to have shown. So in this case, since we're going to look at rotational velocity with the derivative, we'll call it degrees per second. Of course, we do need to change where this signal processing operation is being applied to. And so we'll go ahead and change the name here. Instead of the pelvis acceleration, we're going to look for our hip abduction signal. So we got hip abduction. This is for the left and the right. And we still have our other processing options applied to those acceleration signals. So you can keep loading these operations in here, as many as you need, and apply those to all the different types of signals, and just use this point and click architecture to really, again, improve that data, improve the signal quality, remove artifacts, or highlight, certain aspects of the data that you want to focus on. And in this case, again, we can just click preview. Our acceleration signal, of course, remains unchanged, but now you can see with the hip abduction, we're represented as degrees per second. This one typically zooms out like that, and so you do want to zoom in to get back to seeing a nice scale here. But you can see how even with the derivative, it's going to carry through some noise. So there's some, jagged options here. And so this is something where maybe you'd want to filter this out even further, and perhaps, look at like the peak to peak and try and like smooth it out a little bit. And so in this case, we'll look at here, it's about 0.4 seconds or 40 milliseconds, or 0.04 seconds, sorry. And so we can add some smoothing, for instance. And again, just applied to our hip abduction. We're going to do an RMS, not an RMS, but an average smoothing. And we'll do it with for 40 milliseconds and see how that actually manipulates the signal even further. So if we click preview, it's going to make that change. Zoom in here. You can see how that jagged response, or that sort of two peaks that were back to back, probably just from some noise being pushed through the derivative, went away, and we have a bit more of a smoother signal now to operate while still maintaining some of those peak values that we had seen previously. So I can have this applied, and now that's the signal that we're working with. And of course, we can still continue to look at those options and maybe make some other adjustments. In this case, maybe we want to see how this smoothing actually affects the signal now. So right now we've got this 40 millisecond smoothing operation applied. Let's go ahead and just delete these from our operations menu here. And we're going to apply this to an already smooth signal here. So we're going to not clear the processing first and work with our current process signal. So in this case, maybe we want to smooth it out even further, right? We want to do a 10 millisecond smoothing option to add that. Click preview. You can see how it just keeps getting smoother and smoother and smoother. So maybe we do 100 milliseconds. Really changes things. So you can even look at the differences between two different types of signals with different processing options already applied. So keep that in mind as well. Again, if you want to save it, just click OK. You've got that freedom to be able to create those different configurations and use them for batch processing options. And of course, don't forget about the formula editor as well to do more sophisticated or complex processing and customized processing options. That's going to be it for our MR3 101 session today. We'll go ahead and start with some questions, but I appreciate everybody for jumping on and look forward to speaking with you next time. Thanks.